Z-transform. Z-transform changes one form to another form. In Z-transform, we change discrete time signal to frequency domain. Whereas in inverse Z-transform, we change a function already existed, that is a frequency domain. We change frequency domain to time signal, the existing signal processing. And mathematically we represent inverse Z-transform as Z inverse f of z, that gives f of n, where Z inverse is called inverse Z-transform operator. Okay, these are some basic formulae of Z inverse. Z inverse of z by z minus 1, and Z inverse of z by z minus a is a power n, Z inverse of z by z minus 1 whole square n, Z inverse of z square plus z by z minus 1 whole cube, that is n square, and Z inverse of exponential function e power 1 by z is 1 by n factorial, and Z inverse of a z by z minus a whole square equal to n into a power n. And another important formulas, Z inverse of log of z by z minus 1 is 1 by n, Z inverse of z into log of z by z minus 1 is 1 by n plus 1, and Z inverse of z square minus z cos theta by z square plus 2z cos theta plus 1 is cos n theta, and Z inverse of z sin theta by z square minus 2z cos theta plus 1 is sin n theta, and z square of z square, so Z inverse of z square by z square plus 1 is cos n pi by 2, Z inverse of z by z square plus 1 is sin n pi by 2. These formulas have to remember to solve the inverse Z transform. Now we will take one simple example here. We will find out Z inverse of z by z square plus 11z plus 24. Okay, so we find out the solution for this. Z inverse of z by denominator, we write z square plus 11z plus 24 as factors of z plus 3 and z plus 8. So this is z by z plus 3 into z plus 8. Now by resolving it into partial fractions, we write this as z by z plus 3 minus z by z plus 8. Then in numerator it remains 5, so we divide it with 5 here, then we get 1 by 5 to z inverse of z by z plus 3 minus z by z plus 8. By using partial fractions, write this one. So now this is equal to 1 by 5 into z inverse of z by z plus 3 minus z inverse of z by z plus 8. So this is of the form z inverse of z by z plus a. So this is of the form z inverse of z by z plus a, that is minus a whole to the power of n, and here also we have z inverse of z by z plus 8, that is also in the form of z inverse of z plus a. So now the solution is 1 by 5 into minus 3 whole to the power of n minus 8 whole to the power of n. So this is the solution for the given one. So first we apply partial fractions, then write the formulae. Okay, this is a very simple example. Now we will see another one. Z inverse of 4z square minus 2z by z cube minus 5z square plus 8z minus 4. So let us take this as f of z. F of z equal to 4z square minus 2z by z cube minus 5z square plus 8z minus 4. Then we rewrite this equation in the form of f of z by z by taking z as common in numerator and we cross multiply to the left side. Then we have f of z by z here. Now the numerator becomes 4z minus 2 by z cube minus 5z square plus 8z minus 4. Okay, so we rewrite the given equation in the form of f of z by z equal to 4z minus 2 by z cube minus 5z square plus 8z minus 4. And this can be written as 4z minus 2 by, the factors for this is z minus 1 into z minus 2 whole square. Then the partial fractions made so easy if we write like this. Okay, so this can be written as a by z minus 1 plus b by z minus 2 plus c by z minus 2 whole square. Now f of z by z is a by z minus 1. We have a value is 2 by z minus 1, b value that is minus 2 by z minus 2 plus c value is 6 by z minus 2 whole square. So using partial fractions we get a, b and c values. By substituting a, b, c we get this equation f of z by z equal to 2 by z minus 1 minus 2 by z minus 2 plus 6 by z minus 2 whole square. Now by cross multiplying with this z to the right side, then we have f of z equal to 2 into z by z minus 1 minus 2 into z by z minus 2 plus 6 into z by z minus 2 whole square. Here we are solving for f of n. To get f of n, we apply inverse Z transform on both sides. By taking inverse Z transform, so we have Z inverse of f of z equal to, so we are applying inverse transformation here. So Z inverse of f of z equal to 2 into Z inverse of z by z minus 1 minus 2 into Z inverse of z by z minus 2 plus 6 into z inverse of z by z minus 2 whole square. So now this is equal to 2 into, this is of the form z inverse of z by z minus 1. By basic formula the value is 1, f of n value is 1 here, minus 2 into z inverse of z by z minus 2, that is z inverse of z by z minus a form, a power n. So here it is 2 power n plus 6 into, so here z inverse of z by z minus 2 whole square. So by using basic formula again, z inverse of z by z minus 2 whole square is n into 2 power n. So this is the solution for the given problem. Okay. Now we will see another one. Z inverse of z by z minus 1 into z square plus 1. We find out the solution for this. Now the solution is, we take f of z as z by z minus 1 into z square plus 1. Okay. So by cross multiplying with this z to the left side, so we have f of z by z equal to 1 by z minus 1 into z square plus 1. Okay. So by using partial fractions, this can be written as 1 by z minus 1 into z square plus 1 can be written as a by z minus 1 plus bz plus c by z square plus 1. So we resolve it into partial fractions. 1 by z minus 1 into z square plus 1 can be written in a partial fraction as a by z minus 1 plus bz plus c by z square plus 1. So we find out the values of a, b and c here. Then we will get a value is 1 by 2. Then we have 1 by 2 into z minus 1. B value is minus 1 by 2 z by z square plus 1. See here, bz by z square plus 1. Bz by z square plus 1 plus c value. I get c value is also minus 1 by 2 by using partial fractions. C value is also 1 by 2 into 1 by z square plus 1. So this is f of z by z. On left side we have f of z by z. Now by cross multiplying with this z, so we have 1 by 2 into z by z minus 1 minus 1 by 2 into z square by z square plus 1. So already we have z here, and by cross multiplying we will get z square term here minus 1 by 2 into the last term z by z square plus 1. Now by applying the inverse transformation on both sides, so we get z inverse of f of z. Z inverse of f of z as 1 by 2 into z inverse of z by z minus 1 minus 1 by 2 of z inverse of z square by z square plus 1 minus 1 by 2 of z inverse of z by z square plus 1. And we know the formulas for z by z minus 1 inverse transformation, z square by z square plus 1 inverse transformation, and z by z square plus 1 transformation. Then f of z gives by taking 1 by 2 as common into z by z minus 1 inverse transformation is 1 minus z inverse of z square by z square plus 1, that is transformation of cos n pi by 2. Next again minus z by z square plus 1, that is the transformation of sin n pi by 2. So this is the solution for the z inverse of z by z minus 1 into z square plus 1. Okay. Now convolution theorem, the statement of convolution theorem. So similarly as the Laplace transform or Fourier, we have convolution theorem for Z-transform also. If Z inverse of f of z equal to f of n and Z inverse of g of z equal to g of n, then Z inverse of convolution of f of z and z of z. The product of two functions f of z and z of z, we read it as a convolution of f of z and z of z. So Z inverse of f of z into z of z or convolution of f of z and z of z gives summation of sigma m equal to 0 to n f of m g of n minus m. So the convolution of f of z and g of z, z inverse of f of z and g of z is sigma m equal to 0 to n f of m into g of n minus m, or sigma m equal to 0 to n f of n minus m into g of m. So this is the statement of convolution theorem. So now we will find out z inverse of z square by z minus 4 into z minus 2 using convolution theorem. In particularly, if the question is solve the inverse transformation using convolution theorem, then we use in convolution theorem only. We don't apply we don't use partial fractions here. We apply convolution theorem. If the question is using convolution theorem, solve z inverse of z inverse of f of z. Okay. So now we find out this. So the solution for this by using convolution theorem. We take this as f of z equal to z by z minus 4 and z of z equal to z by z minus 5, because by convolution theorem we have z inverse of f of z into z of z. So here we have two terms, f of z into, this is the product of f of z and g of z. So we take f of z as z by z minus 4 and g of z as z by z minus 5. Then by applying inverse transformation, z inverse of f of z equal to z inverse of z by z minus 4. So this gives f of n as 4 power n. Okay, so z by z minus 4 is 4 power n. Z inverse of f of z is f of n. So we'll find out f of n, and similarly we apply inverse transformation for g of z also. Then we have z inverse of g of z equal to z inverse of z by z minus 5. So this is implies I get the g of n as 5 power n. So we'll find out f of n and g of n here. Then by using convolution theorem, so we have z inverse of f of z and g of z equal to sigma m equal to 0 to n f of m into g of n minus m. So this is the statement of convolution theorem. By convolution theorem, we have z inverse of f of z into g of z equal to sigma m equal to 0 to n f of m into g of n minus 1. Now, which is implies z inverse of f of z into g of z gives z square by z minus 4 into z minus 5, which is equal to sigma m equal to 0 to n f of m, that is 4 power m, g of n minus m, that is 5 to the power of n minus m here. So which can be written as 5 power n into sigma m equal to 0 to n 4 by 5 to the power of n. So we have z inverse of z square by z minus 4 into z minus 5 as 5 power n into sigma m equal to 0 to n 4 by 5 to the power of n. On expanding the summation, so we have 5 power n into, for m equal to 0, so this is m equal to 0 to n 4 by 5 to the power of m. For m equal to 0 we get 1 plus, for m equal to 1 it is 4 by 5, for m equal to 2 4 by 5 whole square plus and so on, and the last term is m equal to n, so we get 4 by 5 to the power of n. So this is of the form 1 plus a square plus and so on a power n. The series which is in geometric progression, and the sum of the series by geometric progression is 1 minus a, that is 4 by 5 to the power of n plus 1 by 1 minus 4 by 5. Okay, so this is geometric progression sum of the series. Okay, and now this is equal to, on simplifying this we get 5 power n into, by taking LCM here we get 5 power n plus 1 minus 4 power n plus 1 by 1 minus 4 by 5, that is 1 by 5, and here the denominator 5 power n plus 1 can be written here, so we get this one, and 1 by 5 into 5 power n plus 1, that is 5 power n. So now we have a 5 power n into 5 power n plus 1 minus 4 power n plus 1 by 1 by 5 into 5 power n plus 1. 1 by 5 into 5 power n plus 1 is 5 to the power of n plus 1 minus 1, that is 5 power n. Then 5 power n and this 5 power n gets cancelled here. Now the solution is 5 power n plus 1 minus 4 to the power of n plus 1. So therefore z inverse of z square by z minus 4 into z minus 5 gives 5 power n plus 1 minus 4 power n plus 1. So this is the solution here. And now, so we'll see the applications of Z-transforms, very important one. Z-transforms are used to solve the difference equations. Okay, so we have a relation like this: yn plus k plus a1 yn plus k minus 1 plus a2 yn plus k minus 2 plus and so on a power a suffix k yn equal to f of n. If we have a relation like this, then this is called as linear difference equation where a1, a2 and so on ak are constants. So to solve this difference equation by using Z transforms. Okay, so we will solve this equation by using Z transforms. To solve this equation, to solve the difference equation, we use shifting properties. Shifting property. So we know that already the statement of shifting property, that is if z of f of n equal to f of z, then z transformation of f of n plus 1 equal to z into f of z minus f of 0. So for the shifting property of z transformation of yn plus 1 now is, so z transformation of yn plus 1 is z into y of z minus y of 0. So this is shifting property for z transformation of yn plus 1. So next, z transformation of f of n plus 2 is z square into f of z minus f of 0 minus f of 1 by z. And similarly we have z transformation of f of n plus 3 as z cube into f of z minus f of 0 minus f of 1 by z minus f of 2 by z square. So and so on, these formulas using shifting theorem. So to solve this equation, we use the shifting property. Okay. So this is the difference equation. Now we will solve this difference equation by using Z transforms. So the difference equation is given as yn plus 2 minus 3 into yn plus 1 plus 2 into yn equal to 0, given that the conditions y0 is 0, y1 is 0. So that means y of 0 is 0, y of 1 is 0. Now by taking Z transforms to the given difference equation, then we have Z transformation of yn plus 2 minus 3 into Z transformation of yn plus 1 plus 2 into Z transformation of yn. So by taking Z transformation on both sides, we get Z transformation of yn plus 2 minus 3 into Z transformation of yn plus 1 plus 2 into Z transformation of yn equal to 0 on right side we have. Now which is implies by shifting property, Z transformation of yn plus 2 is z square into y of z minus y of 0, or we write y0 minus y of 1 or y1 by z. So this is the shifting property of Z transformation of yn plus 2 minus 3 into Z transformation of yn plus 1, that is z into y of z minus y of 0, or we can write y0 plus 2 into y of n, that is y of z equal to 0. Now which is implies here given y0 is 0 and y1 equal to 1. So the conditions are given y0 is 0, y1 as 1. By substituting these values here, then we have z square into y of z by multiplying with this z square into y of z minus z square into y0 is 0 minus z square into y1. y1 is given as 1 by z. Okay? So by substituting y0 is 0, 0 into z square is 0, and y1 value is given as 1. So 1 by z into z square minus 3z into y of z minus of minus plus 3z into y0. y0 is given as 0, so this is 0 plus 2 into y of z equal to 0 here. Which is implies z square into y of z minus z square by z, that is z minus 3z into y of z plus 2 into y of z equal to 0. So which is implies by taking y of z as common, we get z square minus 3z plus 2. This is the coefficient of y of z. By taking y of z as common term, equal to this minus z will become plus z on this side. So now y of z is z by z square minus 3z plus 2. So this is y of z. To get y of n, we apply inverse z transform on both sides here. So we have y of z equal to z by z square minus 3z plus 2. This can be written as z by, the factors for this are z minus 2 and z minus 1. So the product of z minus 2 and z minus 1 gives z square minus 3z plus 2. Now by using passive fractions, that can be written as z by z minus 2 minus z by z minus 1. Using passive fraction, I write this. So y of z equal to, now y of z is z by z minus 2 minus z by z minus 1. To get yn, I apply inverse transformation on both sides. So z inverse of y of z equal to z inverse of z by z minus 2 minus z inverse of z by z minus 1 by applying inverse transformation on both sides. So now this is implies z inverse of y of z, that gives yn or y of n equal to z inverse of z by z minus 2. This is of the form z inverse of z by z minus a power n. So here we have 2 power n minus z inverse of z by z minus 1. That is the transformation of 1. So the solution is yn is 2 power n minus 1. This is the solution for the given difference equation. Now this is another example. So the difference equation is given as yn plus 2 plus 2 into yn plus 1 plus yn is given as n. Here the function is also given f of n, that is n. The given conditions are y0 and y1 are zeros. Now we solve this difference equation using ZTransform. We apply ZTransform on both sides of this equation. Then we have ZTransformation of yn plus 2 plus 2 into ZTransformation of yn plus 1 plus ZTransformation of yn, that gives ZTransformation of n. So by applying ZTransform on both sides, we have this equation. Now by shifting property, I can write this as z square into y of z minus y0 minus y1 by z plus 2 into z into, so the shifting property for this z transformation of yn plus 1, that is z into y of z minus y0 plus z transformation of yn, that is y of z, and equal to, here z transformation of n. Z transformation of n is z by z minus 1 whole square. So if you know the basic formula of z transformation of n, then write this as z by z minus 1 whole square. And now this is equal to, by substituting y0 and y1 as 0, then we get the equation as z square plus 2z plus 1 into y of z equal to z by z minus 1 whole square. Because by substituting y0 is 0, the term will become 0, and y1 is 0, then this is also 0. Similarly here, by substituting y0 equal to 0, we get 0, then the remaining terms are z square plus 2z plus 1 into y of z equal to z by z minus 1 whole square. So now this can be written as y of z equal to z by z square plus 1, so z plus 1 whole square into z minus 1 whole square. So this is the expansion of z plus 1 whole square. On cross multiplying, we get z by z minus 1 whole square into z plus 1 whole square. So now this implies y of z by z equal to 1 by z plus 1 whole square into z minus 1 whole square. And we will find out this by using passive fraction. We resolve it into passive fractions and we write y of z by z in the next slide. So we have y of z by z equal to 1 by z minus 1 whole square into z plus 1 whole square. By resolving it into passive fractions, write a by z minus 1 plus b by z minus 1 whole square plus c by z plus 1 plus d by z plus 1 whole square. So we resolve it into partial fractions. Then we will find out a, b, c, d values. We have a value as minus 1 by 4 into 1 by z minus 1 plus b value is 1 by 4 into 1 by z minus 1 whole square, and I get c value is 1 by 4 again. Then this is 1 by 4 into 1 by z plus 1. D value is also 1 by 4 into 1 by z plus 1 whole square. So by using partial fractions, we resolve it into a by z minus 1 plus b by z minus 1 whole square plus c by z plus 1 plus d by z plus 1 whole square. Then by finding a, b, c, d values and substituting a, b, c, d values here, we get this equation. Then by cross multiplying with this z, so this is y of z by z. On cross multiplying with this z, we will get y of z equal to minus 1 by 4 into z by z minus 1 plus 1 by 4 into z by z minus 1 whole square plus 1 by 4 into z by z plus 1 plus 1 by 4 into z by z plus 1 whole square. So this is y of z. To get yn, we apply inverse z transform on both sides. Then we apply inverse transformation. We have z inverse of y of z. Z inverse of y of z equal to, by taking 1 by 4 as common here, then we have z inverse of z by z minus 1. So minus, so here we have minus 1 by 4. We are taking 1 by 4 as common. Plus z inverse of z by z minus 1 whole square plus z inverse of z by z plus 1 plus z inverse of z by z plus 1 whole square. And now this is equal to 1 by 4 into z inverse of z by z minus 1, that is 1. Here we have a negative sign minus, so it is a minus 1 plus z inverse of z by z minus 1 whole square. Z inverse of z by z minus 1 whole square formula is for n plus z inverse of z by z plus 1, that is a minus 1 whole to the power of n plus z inverse of z by z plus 1 whole to the whole square, that is a formula for n into minus 1 whole to the power of n. So this is a solution for the given difference equation. Here z inverse of y of z, that is yn. So yn is the solution here.